Microsoft's most ambitious Windows projects were almost erased from history, never meant to be seen, let alone remembered. In the early 1990s, a plan called Cairo promised to make your computer almost psychic, only to collapse in public failure. These lost versions didn't just vanish, they shaped the Windows you use today in ways you were never told. So why did Microsoft hide their boldest ideas? And what secrets still haunt your desktop? In 1991, Microsoft unveiled a vision that sounded like science fiction, a Windows operating system that could understand your files, not just store them. The project was called Cairo, and at its core was the Object File System, OFS. Instead of thinking about files as simple documents and folders, Cairo treated every file as a rich object packed with metadata. A report was not just a document, it knew who wrote it, what project it belonged to, when it was last changed, and even how it connected to other pieces of information. This was not just for show. Cairo promised that you could ask your computer for every budget spreadsheet from 1992 or all emails related to Project Athena, and the system would instantly gather them, no matter where they were stored. The secret to this magic was a new approach to organizing data. OFS was built around the idea of smart folders, collections that automatically filled themselves based on your queries. If you needed all the presentations from a certain client, you did not have to dig through endless directories. The folder would appear, already filled with exactly what you asked for, thanks to deep indexing and a search engine woven into the operating system itself. Under the hood, everything in Cairo relied on Microsoft's Component Object Model, COM. This meant that every file, folder, and even system service acted as a programmable object. Developers could build applications that talked to these objects directly, linking data and features across programs in ways that had never been possible before. Cairo's architecture extended to the desktop too, with a shell designed for dynamic, context-aware navigation. The vision was so big, it filled binders with technical plans and inspired a generation of engineers to think beyond the limits of old-school file systems. Bill Gates championed this approach as his dream of information at your fingertips. Cairo was supposed to be the engine that made it real, a Windows that did not just store your work, but understood it. The ambition was electric. For a moment, it seemed like Microsoft was about to deliver a kind of digital intuition years ahead of its time. At the 1993 Professional Developers Conference in San Francisco, hold on a minute, if you're enjoying what you see so far, I hope you'll consider subscribing. It helps me preserve the history of these untold tech stories. Now, let's continue. Microsoft rolled out Cairo for the world to see. The room was packed with developers and tech press, all waiting for a glimpse of the future. But as the demo began, the promise of information at your fingertips started to unravel. Key features simply refused to work. The much-hyped object file system, supposed to deliver instant search and smart folders, struggled to index even small sets of files. When engineers tried to show off real-time queries, the system lagged, stumbled, and sometimes crashed altogether. Behind the scenes, the indexing engine was devouring resources. Early performance tests showed that Cairo's deep metadata scans could slow down NT machines by as much as 40%. Unacceptable for any business, let alone an operating system meant to lead the next decade. The fallout was immediate. Executives left the conference floor with doubts instead of excitement. Internal memos circulated, tallying missed deadlines and spiraling costs. Cairo's planning binders, 3 inches thick, became a symbol of how ambition had outpaced reality. Engineers debated late into the night about whether the core ideas could ever work on the hardware of the day. Some argued for scaling back, but the vision was all or nothing. The deeper the team dug into COM integration and object-oriented architecture, the more complex and fragile the system became. Compatibility with existing Windows apps was a constant headache, forcing redesign after redesign. By 1995, Cairo was quietly shelved. No official announcement, no press release, just a gradual retreat as features were picked apart and reassigned to other teams. The object file system never shipped. The dream of a smart, self-organizing Windows faded into the background, replaced by more practical projects like Windows 95 and NT 4.0. Inside Microsoft, the failure of Cairo became a cautionary tale. Overreach, endless planning, and missed demos had exposed the limits of even the world's biggest software company. The lesson would echo through every ambitious project that followed. By 1996, the next big leap for Windows was code-named Nashville, and its ambitions were nothing short of radical. The idea was to erase the boundary between your desktop and the internet. Engineers pictured a world where every file, folder, and web page lived side by side, all accessible from a single, seamless interface. At the heart of this vision was shell integration, a technical blueprint that would let users browse web pages and local files in the same window. No more jumping between programs. The desktop itself could become a living canvas, powered by real-time web content. Animated headlines, weather updates, and stock tickers could appear right on your wallpaper, thanks to a feature called Active Desktop. Prototype demos in 1996 showed off HTML-based folders, live widgets, and an Explorer window that doubled as a web browser. For users, it promised a more connected, dynamic experience, one where the internet felt like a natural extension of the operating system, not an add-on. Developers were excited by the possibilities. ActiveX and COM would let them build custom gadgets and interactive content, all woven directly into the desktop. For a brief moment, Nashville made it look inevitable that the future of Windows would be fused with the web at its core. Microsoft's legal department watched Nashville's progress with growing anxiety. By mid-1996, internal memos warned that tying Internet Explorer directly into the Windows shell could trigger a federal investigation. The Justice Department had already started circling, gathering evidence that Microsoft was using its dominance in operating systems to crush browser competition. Lawyers flagged the risk. Shipping Nashville as a full release, with seamless browser integration, might hand regulators the proof they needed for an antitrust case. Senior executives weighed the technical breakthroughs against the legal fallout. The verdict came down quickly. Nashville would not ship as a standalone version. Instead, its most ambitious features, like active desktop and unified browsing, were quietly folded into Internet Explorer 4 and later, Windows 98. The legal team's caution changed the course of Windows development. Innovation was no longer just a technical challenge, it had to survive the scrutiny of government lawyers. Nashville's cancellation showed that sometimes the biggest threat to a new Windows was not a bug, but a brief from the Department of Justice. By the end of the 1990s, Microsoft's Windows development was spiraling in two directions at once. On one side, the consumer team pushed forward with the Windows 9X line, fast, flexible, and familiar, but notorious for crashes. On the other side, the business division built the NT series, stable, secure, but stiff and less compatible with popular games and home software. Each camp guarded its own code, tools, and priorities. As pressure mounted to create the next big leap, engineers found themselves tangled in a web of competing requirements, duplicated features, and endless integration headaches. New ideas bounced between teams, sometimes landing in both branches, sometimes in neither. Feature lists grew longer, but so did bug reports and missed deadlines. Developers swapped war stories about builds that worked on one branch but broke on another. Testing became a maze, with small changes triggering unexpected failures across distant parts of the codebase. The more Microsoft tried to bridge the gap, the more the differences multiplied. Two operating systems evolving in parallel but never quite meeting in the middle. Internal emails described the environment as organized chaos, with managers struggling to track what had actually shipped, what was still in development, and what had quietly been abandoned. For the engineers, the sense of confusion was everywhere. Meetings stretched for hours as teams tried to align roadmaps that no longer fit together. Some developers kept private logs just to remember which features belonged to which version. Even veteran programmers admitted they sometimes lost track of which bugs applied to which branch. The split had become unsustainable, and everyone inside Microsoft could feel it. Something drastic would have to happen to break the cycle. In early 2000, as Neptune and Odyssey collapsed in a tangle of conflicting priorities, a memo landed in the inboxes of Microsoft's core Windows engineers. The order was blunt: wipe all source code and project materials from the servers. No trace of the failed consumer and business branches was to remain. But inside the war rooms and late-night offices, a quiet resistance took shape. A handful of engineers, convinced that the work wasn't wasted, quietly made personal backups, archiving code, design notes, and prototype features onto spare drives and hidden directories. These weren't just acts of nostalgia. They were a bet that the best ideas could still find new life. When the dust settled, a new project surfaced from the ashes. Codenamed Whistler, it drew directly from the secret archives of Neptune and Odyssey. Engineers pooled together the most stable code, borrowing fast user switching from Neptune and advanced system management from Odyssey. The result was a unified foundation, one operating system that could finally bridge the gap between home and business. Whistler's development moved with a focus and urgency that had eluded the split teams. By late 2001, Whistler was ready for the world as Windows XP, a release that would become the backbone of personal computing for more than a decade. The story could have ended with a purge, but instead, the quiet determination of a few engineers preserved the DNA of what came before. Their decision turned a moment of loss into the birth of an icon. Yet, as XP took its victory lap, the lessons of overreach and unchecked ambition were already beginning to fade from memory, setting the stage for the next great leap and the next great fall. Longhorn began as a promise to deliver the future that Cairo could never reach. The centerpiece was WinFS, a file system designed to blur the line between documents, emails, photos, and even music. WinFS would let users search by meaning, not just by name or folder. For example, all contracts from last quarter, all photos from the Seattle trip, or every email with an invoice attached. Engineers dreamed of a world where every piece of data was connected, instantly retrievable, and smart enough to anticipate what users needed next. But as planning sessions dragged on, the scope ballooned. WinFS was no longer just a file system. It was a platform, a database, a new way of thinking about storage. Feature lists swelled, deadlines slipped, and integration with other parts of Windows became a nightmare. Developers struggled to keep up as requirements shifted and new technologies were tacked on. By 2004, the pressure inside Microsoft was mounting. Hundreds of engineers were tangled in a web of dependencies. Test builds crashed under the weight of unfinished features. WinFS alone consumed vast resources, slowing progress on everything from graphics to security. The more ambitious the vision, the more fragile the code became. With each passing month, the list of bugs grew longer and the odds of shipping a stable product shrank. Then, just as the team was reaching its breaking point, a new crisis hit. On August 27, 2004, Build 5111, an internal Longhorn alpha, leaked onto public forums. The build contained unfinished versions of WinFS, experimental user interfaces, and private development documents. Within hours, screenshots and early code were dissected by enthusiasts and critics alike. The leak was not just embarrassing, it exposed the project's instability to the world. Microsoft's security team launched an internal investigation, combing through server logs and email trails in a desperate search for the source. Rumors of a mole hunt swept through the hallways. Every team member's access was scrutinized, and the sense of trust inside the division began to crack. Behind closed doors, the mood turned anxious. Leadership faced a dilemma: keep pouring resources into a project spiraling out of control, or admit defeat and start over. The leak made it impossible to ignore the scale of the problem. Engineers who had poured years into WinFS watched as their work was picked apart on public message boards. The sense of impending collapse was everywhere. No one knew what would survive the fallout, or if the dream of a smarter Windows was about to vanish for good. On August 26, 2004, inside a closed-door meeting at Microsoft, Jim Alchin delivered the order that would change the course of Windows forever. The message was blunt: stop everything. Years of work on Longhorn were to be wiped away, the codebase abandoned, and every engineer reassigned. The grand vision that had driven hundreds of developers, the promise of WinFS and a smarter, more connected Windows, collapsed in a single afternoon. Alchin's directive meant more than just shelving a few features. Entire teams watched as their contributions vanished overnight. Some had spent years building the database-driven file system that was supposed to realize Bill Gates' dream of information at your fingertips. Now, those ambitions were dead. The WinFS project, once the crown jewel of Longhorn, was paused indefinitely. Later, on June 23, 2006, Microsoft confirmed that WinFS would never ship, not with Vista, not as a standalone product. The mood inside the Windows division turned somber. Senior engineers described the atmosphere as total demoralization. Some left the company, others were shuffled to SQL Server or Search, trying to salvage what they could from the ruins. Meeting notes captured the shock, years of effort erased in a single decision. The reset was not a careful rewrite or a strategic pivot. It was a hard stop. It was a break with Microsoft's tradition of building on top of old foundations. The new plan was to start fresh, using Windows Server 2003 Service Pack 1 as a clean base. No new features, no experiments, just a relentless focus on stability and security. The fallout rippled beyond the code. Morale hit rock bottom. Developers who had poured themselves into WinFS and the Longhorn vision found themselves reassigned, their work scattered or lost. Some of the most talented engineers moved on, taking with them years of hard-won experience. Others stayed, determined to see something ship after so many false starts. When Vista finally arrived, it was a shadow of what Longhorn had promised. Critics called it compromised, haunted by the ghosts of canceled features. For Microsoft, the reset was the cost of unchecked ambition, a lesson written not just in lost code, but in the faces of the people who built it. The scars of that decision lingered, shaping how the company would approach innovation, risk, and failure for years to come. Innovation often hides in plain sight, shaped by experiments that never officially see the light. As Microsoft now leans into artificial intelligence-driven platforms, echoes of these abandoned visions resurface in features we take for granted. The tech we use tomorrow will always be haunted by ideas that almost vanished. Sometimes, what isn't released shapes the future most. Which unrealized Windows would you want to use? Thank you for watching. I'd be genuinely interested in hearing your opinion on this in the comments. If you want to see more videos like this, please make sure to subscribe. There's much more to come.